Okay, I wanted to give a summary of the Desmos video. If everything in there made perfect sense, you can skip this, but here I'm going to go into, I just want to write everything down so you have a good copy of it. So I'm going to look at a greater than 1. So our example at Desmos was y equals 2 to the 1, 2 to the t. And what I want to look at is this function, f of t equals b a to the t, where a is greater than 1. And remember, for now at least, b has to be greater than 0. Okay. So we saw that the graph looked like this. And I want to do a table of values. So when t is equal to 0, we're going to get b is equal to a to the 0. And we saw in the exponent video, which you can review if you want, that that's equal to b. So that's our y-intercept, 0, b. I think that's one reason why they chose that as the y-intercept. We saw that if we continue this, that the graph heads to 0, levels off to y equals 0. So what we're going to get here is we're going to get a horizontal asymptote on the left of y equals 0. Because this graph is heading to y equals 0. Here, this goes to infinity. And that's going to mean there's on the right, or nowhere, there's nowhere no vertical asymptotes. Okay. We saw that we can plug in any real number. The graph makes sense for any real number. Because a to a positive power, we know what that means. A to a negative power, that's permissible too. So the domain is going to be equal to all real numbers. We saw the graph is always above the x-axis. So that means that the range is going to be 0 to infinity, but above 0, so that gets a parenthesis. So that's since the range has to be greater than 0, there's no 0, so there's no x-intercept. Lastly, we see the graph starts near 0 and keeps rising, so it's always increasing. Okay, now what I want to do is look at the case where 0 is less than a, but a is less than 1. And again, we're going to look at the same function. And just quick table of values, actually not many at all. When t is 0, that was supposed to be b a to the t. So when t is 0, we get b a to the 0, which is b. We saw the graph was like this. So here it levels off at y equals 0. So we have a right horizontal asymptote. Of y equals 0. The graph starts at infinity and then heads down. Okay. So we're going to see that it's always decreasing. Okay. We saw that the y-intercept was at 0, b. As with the case a greater than 0, there's no vertical asymptote. The domain, again, is going to be all real numbers. If we can take any power of a, we can take any power of a when it's less than 1. No problem. The range is the same, always above the x-axis. So I'm going to just make that note here, always above the x-axis. So we have the same property, no x-intercept. And I don't think I forgot any of the important properties. Okay. So I just want to do one more thing and then we're done. I want to compare f of t equals 2 to the t to f of t equaling 1/2 to the t. Notice that 1/2 is equal to 2 to the minus 1. So that means I can rewrite this function as 2 to the minus 1 t. Now remember, what we saw in the exponent review was that if I take an exponent to a power, I multiply. So a to the m to the power of n is a m times n. I can do that here, and I get 2 to the minus t. So I'm going to call this g of t, sorry, just so I have a different name. So g of t is equal to 2 to the minus t. Notice, g of t equals f of minus t. Remember, f of t is going to be 2 to the t, so that's going to be 2 to the minus t. That's exactly what that is. So here, remember, when you switch, when you multiply what's inside the function t by minus 1, you reflect across the y-axis. That's why this is the graph of y equals 2 to the x, 2 to the t, I'm sorry. And then over here, I know I'm going to mess this up, so let me do this so I can fix it. This is going to be the graph of y equals 1/2 to the t, which is 2 to the minus t. This is just a reflection across the x-axis, y-axis, I'm sorry. Okay, that's all I have. Yeah, that's it. Okay, thank you very much. Bye-bye.